IBESS, Climate Change and Energy Production, Part 1, will introduce energy choices by societies and energy security. The significant ideas are: there is a range of different energy sources available to societies that vary in their sustainability, availability, cost, and socio-political implications. The choice of energy sources is controversial and complex. Energy security is an important factor in making energy choices. Here is the outline of all the available movies in the Climate Change and Energy Production unit. Use this outline to find the movie you need for review. This movie is focused here. Here's an outline of the range of energy resources available to societies. Take notes from this slide. We have non-renewable energy resources and we have renewable energy resources. Keep in mind that each source of energy has its advantages and disadvantages. I will provide detail about each of these energy sources in parts 2 and 3 of this unit. The significant divide among sources of energy lies between non-renewable energy, fossil fuels primarily, and renewable energy sources, energy provided by the power of the sun. Wind, which drives the turbines seen in the lower photo, result from uneven heating of the Earth's surface by the sun. Here are the first 2 IB syllabus statements that drive this movie. Discuss the factors which affect energy security. Secondly, energy security depends on adequate, reliable, and affordable supply of energy that provides a degree of independence. Unequitable availability and uneven distributions of energy may lead to conflict. Energy security is defined in this statement. Listen carefully as I speak through this slide. Energy security is defined as the uninterrupted availability of energy sources at an affordable price. Energy security is the adequate, reliable, and affordable supply of energy that provides a degree of independence. Take a note. Energy security primarily means energy independence. In other words, free from the dependence on other countries for energy. Energy security results from what's available and how much there is. Many Middle East countries have energy security because the amount of available fossil fuel is substantial. But fossil fuels are non-renewable, so energy security can change depending on how the energy is used. Could societies choose energy sources that are more sustainable than other sources? Yes, they could. Keep in mind that each source of energy has its advantages and disadvantages. The uneven availability of oil provides some countries with energy security while other countries have less security. An inequitable availability and uneven distribution of energy may lead to conflict. If country A supplies country B with its oil, country A has leverage over country B. This uneven relationship with respect to energy could lead to conflict. Certainly, country B has less energy independence than it might like. Energy security depends in part on the socioeconomic status of the society. Some societies demand more energy than others, as you can see in the images on the left. Furthermore, energy security could be enhanced by reducing energy needs, as you can tell from the images on the right. Energy needs have changed over time. Societies have moved from reading by candle to reading on devices that require electric energy. Societies have moved from relying on the food eaten by animals for long-distance transport to relying on fossil fuels. Energy needs change over time, as you can see in this graph. Before 1800, wood, biomass, was the primary source of energy for societies. Then coal was discovered and the need for wood decreased. Then the technology to drill for oil resulted in the decline of coal, and then natural gas will result in the decline of the use of oil. It's interesting to note that per capita consumption of biofuels, wood and dung, decreased in the 20th century. That said, biofuels, wood and dung, remain very important to less economically developed societies. But per capita use of biofuels, per capita use has declined with the arrival of other energy sources, primarily non-renewable fossil fuels. Now, here are the definitions for energy security at the top of this slide. Stop the movie now and take some notes. The factors which affect energy security are ecological, the natural availability of certain energy sources; political, relationships with suppliers; socioeconomic, the demand for energy by the society; and population growth, which influences demand; economic, the cost of energy; cultural, the choices made by societies related to energy security, such as conservation of energy, societal tolerance for nuclear energy, and environmental issues, which impact cultural choice. As well, there are technological factors, the technology to produce energy, and then, and lastly, efficiency of energy use. As I've mentioned, some locations have readily available sources of energy and some do not. An inequitable availability and uneven distribution of energy may lead to conflict. Some locations are adjacent to coastlines that could be developed for wind power, but not all locations in the world experience wind. This is the Itaipu Dam in Brazil, the dam that produces the most electricity in the world on a yearly basis. Brazil has large rivers, while Saudi Arabia does not. Variation in the spatial distribution of water influences the availability of certain energy resources. Desert biomes experience large quantities of solar energy. Solar panels take advantage of the light. Societies in desert biomes might choose solar energy due to its availability. Variation in primary productivity, NPP, influences the availability of certain energy resources. Rainforest biomes have more biomass energy than desert biomes. Now let's look at the political factors that influence energy security. This is a map of gas pipelines across Europe, and most of the gas flows in one direction from Russia to Western Europe. Many countries in Europe depend on Russia's supply of gas. What you might see in this map is an outline of political relationships fraught with potential conflict over energy. Russia has political leverage over countries that depend on Russian gas. And if serious disagreements erupted, Russia could stop the supply. Now let's look at the socioeconomics of demand. This graph displays per capita energy consumption as a function of per capita GDP, which is a close relative of the average income per person in that society. The higher the income, the higher the energy use. More economically developed countries use more energy than less economically developed countries. Higher use of energy creates a higher need. A higher requirement for energy influences energy security. What are the energy needs of a country? Higher use of energy creates a higher need. A higher requirement for energy influences energy security. Is the country developing, moving from LEDC status to MEDC status? This will impact energy needs. Another socioeconomic factor that influences energy security is how large is the population and is the population growing? This graph displays population size over time in various countries. You can see that China and India are both large countries, lots of people that require energy, and a growing population will require more energy in the future. Now let's look at the economic influences on energy security, and we'll keep this simple, looking at nothing more than the cost of energy. In this slide, you can see the price of crude oil in dollars per barrel from about 1987 out to 2015. When the prices go up, the energy is less affordable, thus energy supply is less secure. This slide presents a rough estimate of energy source cost using U.S. prices as a guide. My interest here is to talk in general terms and relative terms, but not specific terms. You can see that solar voltaic energy is expensive, while coal, nuclear, and hydro are all less expensive. The cost of an energy source influences its availability, thus impacting energy security. The cost of an energy source influences societal choice of energy. Societal choice of energy will be the subject of part 4 in this series. In this slide, you can compare costs among various energy sources. The cost of energy will vary season to season, keep that in mind, year to year, and country to country. But I do want to make the point that generally, fossil fuels tend to be cheaper than renewable energy sources, and this impacts energy security and societal choice. Now let's look at the cultural factors that influence energy security, and this has to do with the choices made by societies, such as conservation, tolerance for nuclear energy, and environmental issues. Culturally, societies can choose to conserve energy, use less energy by turning off the lights or by using public transport. One could increase energy efficiency by using special windows that let less heat escape. Conserving energy increases energy security. But notice the connection between energy security and energy choice. France produces 75% of its electrical energy needs using nuclear power. Now, not all societies have the same high tolerance for nuclear energy as France. Nuclear accidents such as Chernobyl and Fukushima in Japan have dissuaded societies from adopting nuclear power. But France enjoys energy independence by virtue of its interest in nuclear energy. France enjoys an energy security unparalleled in Western Europe. Nuclear accidents have caused some societies to avoid nuclear energy. Choice of energy influences energy security. The environmental damage, the ecological damage of dams have caused some societies to reduce the use of hydropower. Choice of energy influences energy security. Environmental issues related to fossil fuel use have moved some societies to adopt biofuels. Biofuels come from plants, grasses or corn particularly, that are grown, then fermented to produce ethanol. Ethanol is a potential substitute for fossil fuels. Biofuels could provide energy security. And lastly, let's look at how technology influences energy security. This includes the technology to produce, say, nuclear energy or solar power, but it also includes the technology to increase the efficiency of energy use. Nuclear energy requires technology not available in all countries of the world. The use of nuclear energy provides energy security, but the society must be aware and must be tolerant of the environmental risks. In this photo, you can see what's called concentrated solar power, CSP, where mirrors are arranged to focus the solar energy on one point, where heat drives a turbine to produce electricity. Solar power requires a technology that would increase energy security. And with our focus here on technology, here is a relevant IB syllabus statement. Improvements in energy efficiencies and energy conservation can reduce energy demand and contribute to energy security. Energy efficiency is the percent of total energy that is useful, or in other words, it is the percent of useful energy out of all the available energy. You can see this equation. It is output divided by input times 100. The net energy, the useful energy, is defined as total energy available minus the energy needed to extract, process, and deliver the energy. Stop the movie now to take some notes. Energy efficiency is the net energy divided by the total available times 100, or in other words, the output divided by the input times 100. This net energy is equal to the total energy minus all the energy needed to extract, process, and deliver energy. For example, nuclear energy has a particularly low efficiency because at every step of the processing, some energy is lost. At the end, the useful or net energy is less than 15% of the total. Passive solar energy, such as the energy that is allowed to stream into windows, has a high efficiency. Of all the energy arriving at the window, 90% is useful in heating the room. The efficiency of coal-produced electricity, once extraction, process, and delivery is accounted for, is approximately 40%. Some sources of energy are more efficient than other sources. Efficiency influences energy security and sustainability and energy choice. Let me say that again, take a note. Efficiency influences security, sustainability, and choice. Remember the IB syllabus statement. Improvements in energy efficiencies and energy conservation can reduce energy demand and contribute to energy security. Let me bring this movie to a close by coming back to where I started the movie. There is a range of different energy sources available to societies that vary in their sustainability, availability, cost, and technological developments and socio-political implications. These in turn affect energy security and independence. Here is a table that provides some perspective on the use of different energy choices in MEDCs and LEDCs. As a note, I've color-coded renewable energy sources in green. As you consider renewable sources of energy, be thinking about sustainability. You can see the high use of biomass in LEDCs, thus the smaller percentage of fossil fuel use on a percent basis. Consider sustainability here because biomass energy sources are generated from living organisms. I'll let you stop the movie and spend more time with this slide. In this graph of world energy consumption over time, the first thing to note is the stunning increase in world energy use. This mirrors human population growth as well as an increase in the economic status of many societies. In this graph, we can see that there's a range of energy sources employed by people over time, and we can see change in the relative use of these energy resources over time. Up through the late 1800s, biofuels, wood, and dung were used predominantly. But from the late 1800s until today, non-renewable fossil fuels, seen here as coal, oil, and natural gas, dominate as the sources of energy for societies. You can see that nuclear energy appeared on the scene after the Second World War, mostly after 1960. But nuclear energy does not make up a large part of the world's energy sector. I want to note that hydropower here and biofuels are the only two renewable energy sources on this graph, and neither command a large percentage of the world energy market. In this pie chart, we can see the dominance of fossil fuels once again, and the smaller part played by nuclear energy. Renewable energy represents about 17% of world energy consumption, and most of that is biomass and hydropower. Biomass energy, seen here, is the wood and dung used mostly by people in less economically developed countries. The details in this graph are interesting, and you could spend time studying this graph. Here is a relevant IB syllabus statement. Fossil fuels contribute to the majority of humankind's energy supply, and they vary in the impact of their production and their emissions. The use of fossil fuels is expected to increase to meet global energy demand. This graph displays per capita consumption of energy from 1820 to the year 2000, and it reinforces the idea that Fossil fuels dominate energy use today and have dominated since the early part of the 20th century. It's interesting to note that per capita consumption of biofuels, wood and dung mostly, decreased in the 20th century. Despite the continued strong use of biofuels worldwide, again wood and dung mostly, per capita use has declined with the arrival of other energy sources, most importantly, non-renewable fossil fuels. This graph projects energy demand all the way out to 2040 and beyond, and what's interesting to note is the predicted decline of fossil fuels and the increase in what's noted here as sustainable new technology industries. As you consider the future, consider this IB syllabus statement. Evaluate the energy strategy of a given society. Now, generally, I agree with this graph, except that it includes nuclear energy within this sustainable category. You need to be careful here. Nuclear energy is non-renewable in the same way that fossil fuels are non-renewable. Societies have different levels of energy security and make different decisions on energy choice. Can you evaluate the energy strategy of a given society? Now, all countries today use fossil fuel energy to provide for most of their energy needs, and this is because fossil fuels are cheap. But fossil fuels are non-renewable and cause severe environmental degradation. So, what's the future to hold? What could societies do? Could they increase the efficiency of energy use or reduce use through education or legislation? Or could they choose alternative, more sustainable energy sources? Iceland, for example, could expand its geothermal energy because geothermal energy is available in Iceland. Brazil could develop biomass or biofuels because as a tropical country, its net primary productivity is high. The UK also depends on fossil fuels moved by pipeline from Germany, but the UK could develop wind power along the coast. Now, Venezuela has a lot of oil, and so oil, a non-renewable resource, provides energy security to Venezuela, at least in the short term. And that brings us to the end of IBESS Climate Change and Energy Production, Part 1.